Next problem is if fxy is x square tan inverse y by x minus y square tan inverse x by y if x into y is not equal to 0 and is 0 elsewhere, that is one of them is 0 then also 0 value is 0. When xy is 0, when xy is 0, one of them is 0 or both are 0. So when we use this first definition, if both the x and y are not equal to 0, and if one of them is 0, then write the value, its value is 0, that is either x is 0 or y is 0, then fxy is 0, and show that these fxy 0 0 and fy 0 0 are not equal. So fxy 0 0, the definition is what? Limit k tends to 0. Fxy means the derivative of fx with respect to y, or we consider the derivative of fy with respect to x. So here is the fx, derivative of fx with respect to y. So the derivative with respect to y means limit k tends to 0. Fx 0k minus fx 0 0 divided by k. So this is by using the definition of fy. What is the definition of fy? Limit k tends to 0, f 0 k minus f 0 0 divided by k. This is the definition of fy. And this is fxy. So replace f by fx. So basic definition is what? The basic definitions are so what are the basic definitions? You see the basic definitions of okay. So observe these definitions. What is fxab? Is limit h tends to 0 f of a plus h b minus f of ab divided by h. So this is the definition. What is fxab? Limit h tends to 0 f of a plus h b minus f of ab divided by h if limit exists. What is fx? Fx means dabba f by dabba x or dabba dabba x of f. Okay. So what is fy? AB is limit k tends to 0 means derivative with respect to partial derivative with respect to y means limit k tends to 0, and derivative with respect to x means limit h tends to 0. And if f of a and b are 0 0, then what is the definition? Limit h tends to 0 f of h 0 minus f of 0 0 divided by h. Similarly, the definition of fy ab is what? Limit k tends to 0 f of a b plus k minus f of ab divided by k. Okay. So limit the partial derivative with respect to y means limit k tends to 0. Now what is fy means dabba f by dabba y or dabba dabba y of f. And then what is fx x ab? It is dabba square f by dabba x square ab or dabba dabba x of dabba f by dabba x ab, or it is dabba dabba x of fx. This dabba f by dabba x means fx. This is dabba f by, this is dabba f by dabba dabba x of f. This is dabba dabba x of f. This, and we have to write here dabba dabba x of fx, that is just replace f by fx. So what is fx x ab? Limit h tends to 0 fx a plus hb minus fx ab divided by h. Just replace f by fx, because this is what fx x means what? The derivative of fx with respect to x, and this is the fx means what? The derivative of f with respect to x, and we have to write the derivative of f with respect fx with respect to x, that is just replace f by fx. Okay. Similarly, what is Fxy.AB? Here the meaning of Fxy.AB is what? Dabba square f by dabba x dabba y. That is dabba dabba x of dabba f by dabba y. That is dabba dabba x of Fy. So this is the derivative of f with respect to x, and we have to write the derivative of fy with respect to x. That is just replace f by your f by fy, and so fxy ab is what? Limit x tends to 0, fy a plus hb minus fy ab divided by h. Means what is fxy? What is the meaning of fxy? The derivative of fx, the derivative of fy with respect to x, the derivative of fy with respect to x. And what is this? This is the derivative of f with respect to x. And here, what is fxy? Means the derivative of fy with respect to x. That is just replace f by fy. Okay. And what is fyx? Fyx means the derivative of fx with respect to y. And what is this? This is the derivative of f with respect to y. So just replace f by fx. What is fxy? Fyx. Then what is fyx? The derivative of fx, derivative of fx with respect to y. Just replace in the definition of fy, f by fx. Okay. So sometimes the meaning of fxy is the derivative of fy with respect to x is your meaning. But if we take the fxy in this fashion, that the derivative of fx with respect to y, then this is the definition of this fxy ab. And this is also taken as a derivative of fy with respect to x. Then this is the definition. So the notations are interchange, maybe interchange. We can interchange the definitions of fxy and fyx. That is, take this as a definition of this, and this as a definition of this. Okay. So once if you take the definition of fxy ab as this, then that take the definition of fyx ab as this. Okay. And if we take the fxy ab as this definition, then take fyx ab as this definition. Okay. So fyy ab is what? Dabba square f by dabba y square. Means this is fyy ab means the derivative of fy with respect to y. The derivative of fy with respect to y. And therefore limit k tends to 0. The definition of the, this is the definition of the derivative of f with respect to y. And we have to write fyy means just replace f by fy. Fyy means what? Just replace f by fy. So these are the definitions of second order partial derivatives. These two are the basic definitions. First, fxab and fyab. And these definitions are depend on these first two definitions. Okay. So next problem is this. Problem is what? This is the problem. Yes. Fxy is this, then find fxy 0 0 and fy 0 0. These two are not equal. So fxy 0 0 is what? So here the meaning is what? The fxy meaning is what? The derivative of fx with respect to y. So limit k tends to 0, fx 0 k minus fx 0 0 divided by k. That is substitute a and b as 0 0 0. And then find this fx 0k, fx 0 0. Okay. So and fyx 0 0 is what? The meaning is what? The derivative of fy with respect to x is limit h tends to 0, fy h 0 minus fy 0 0 divided by h. Okay. Or we can take the meaning of this as this, and the definition of fyx 0 0 as this. Okay. So in some book the definition of this is given this definition, and the definition of this is given this definition. Or in some book the definition of fxy 0 0, the meaning of fxy 0 0 taken as a derivative of fy with respect to x, then this is the definition. And if we take the meaning of fyx as the derivative of fy with respect to x, then this is the definition. But if we take the meaning the derivative of fx with respect to y, then this is the meaning. So and then find these all fx 0k, fx 0 0, fy h 0, fy 0 0. First fx 0k. Derivative with respect to x means limit k tends to 0. Here is the limit k tends to 0. uh, limit h tends to 0. This is not fx 0k. This is not fx 0. Fx 0k means limit h tends to 0. This is wrong. This is wrong. Fx 0k is what? Limit h tends to 0. F of 0 plus h, that is hk divided by minus f of 0k divided by h. So write here h, write here h. Okay. Then this is correct. This is correct. Write only in the place of k as h. And then write f of hk as this h square tan inverse h by k, k by h minus k square tan inverse h by k minus fy00 is 0 divided by h, right? H divided by h. Here write limit h tends to 0. Then separately divide by h. So we have h square by h is h and k square by h here, tan inverse h by k. And then adjust for this tan inverse theta by theta. So here is tan inverse h by k. So this write this k square by h as k divided by, that is shift the k square k in the denominator. So we have k by h by k, okay, or divide by h by k, okay. So we have k into tan inverse h by k divided by h. There is already divided by h, so just write divided by k, that is factorize this k square as k into k and shift that k. If we shift the k to denominator, then it becomes 1 by k, that is h into 1 by k is h by k. And limit of this factor, here write h tends to 0, write h tends to 0, correct, here h tends to 0. So h tends to 0, then this tends to 0 because h is 0. But and this is what, this limit of this factor is 1 as h tends to 0 by using this rule. When tan inverse theta by theta is 1, if theta tends to 0. So as h tends to 0, here write h tends to 0, h tends to 0, then tan inverse, then h by k also tends to 0. So theta tends to 0 means tan inverse h by k divided by h by k. This limit is 1 and limit of k is itself k, because limit is h tends to 0. So write it here k, right here k, correction is k, then h tan inverse and its limit is 0. So we have the answer 0, limit of this factor is 0, tan inverse 0 h is 0, infinity, actually tan inverse infinity, don't write this 90. It is actually h is, here is the limit h tends to 0. So tan inverse k by 0 means tan inverse infinity is 90. Okay, so this is 0, 0 into 90 is 0, and this k, limit of k is itself k, and limit of this factor is 1. So right, correction is there, right, limit h tends to 0 here, here write h, here write h, okay. Then the next steps are same, correct, only write h tends to 0 here, okay. So we have the answer minus k. Then the value of fx00. So limit h tends to 0, f of h 0 minus f of 0 0 divided by h. What is the definition? Fxab. Fxab is what? Limit h tends to 0, f of a plus h. A is 0, so a plus h, 0 plus h is 0. Then b is 0 minus f of ab, both are a and b are 0 divided by h. So fh 0, directly write fh 0 is 0, because what is the definition? Fxy is 0 when elsewhere, means x into y is 0. So when x into y is 0, if one of them is 0, that is either x is 0 or y is 0. So one of them 0 is there, answer is 0. So f of h 0 value is 0 because one of them is 0. Y coordinate is 0. F of 0 0 is 0 divided by h. Therefore 0 answer. Then these values fy h 0, fy h 0 is what? Limit k tends to 0, f of, here write only fy 0k, fy 0k, fy 0, fy h 0, right here fy h 0 is limit h tends to 0, f of a is h and b is 0, but 0 plus k is k minus f of 0k divided by k. Here write fy h0. So this is the value of fy h0 right here, fy h0. And then we have f of hk is this, -0 divided by k. Then divide separately by k. We have k square by k is k. h square, and k tends to 0 means here is the adjustment that this limit k 0 means this limit of this factor is 0, and limit of this factor shift this h out of this h square, one h shift to denominator. So that becomes, if we shift h, then it's become 1 by h. So 1 by h into k is k by h. So and the limit of this factor is 1. Limit of h is itself h, and limit of k is 0 as k tends to 0. Limit of tan inverse h by 0, that is tan inverse infinity, is 90 pi by 2. Okay, and so 0 into pi by 2 is 0. So answer is h. And lastly, we find Fy00. Fy00 is what? Limit h k tends to 0. F of 0k minus f of 00 divided by k. That is, substitute a and b both are 0. And both are equal to 0. And answer is 0. And therefore, substitute all these values in equation number 1 and 2 in these equations. We have the answer. Fxy00 limit k tends to 0 minus k, value of that quantity, minus 0 divided by k, that is minus 1, and limit of minus 1 is minus 1. And Fyx00 is limit h tends to 0, h minus 0 by h, because the values are h 0, and 0 h by h is 1, and therefore limit of 1 is 1. So one answer is minus 1, another is plus 1, and therefore these two are not equal. Then the Clairaut theorem, that is when these mixed derivatives are same. That is when fxy ab and fyx ab are same. So there are three theorems on this concept, that when fxy ab and fyx ab are equal, that is when these mixed derivative of second order are equal. So there are three theorems: Clairaut theorem, Squar's theorem, and Young's theorem. So there is only statement of these theorems. Proof is not included in the new syllabus. So just remember the statement. Don't learn these proof. This proof, because proofs are not included in the new syllabus. Only statement are important of these three theorems, that Clairaut theorem, Squar's theorem, and Young's theorem. So first, these what the question is what? Right? State Clairaut theorem. Don't write state and prove. Right? Only state Clairaut theorem. So what is the statement? If fxy and its partial derivatives fx, fy, fxy, fyx as defined throughout on an open region containing a point AB. That is, these are defined or exist, fx, fy, fxy, and fyx at AB. Then, and all are continuous at AB. That is, all these derivatives fx, fy, fxy, and fyx are continuous at AB. Then fxy AB is equal to fyx AB. So the in short statement is what? If these fx, fy, fxy, and fyx are continuous, don't write here constant, write here continuous at AB, then fxy AB is equal to fyx AB. So this is the short meaning of this Clairaut theorem. That is, if the function fx and its partial derivative fx, fy, fxy, fyx are continuous at AB, then fxy AB and fyx AB are equal. So this is the short statement of the Clairaut theorem. That is, the function and its first order partial derivative and mixed order partial derivatives are continuous at AB, then fxy AB and fyx AB are equal. So proof is not important. Proof is not in our new syllabus. So just remember the statement. So next problem is of the same type. The fxy is this: x square into y square divided by x square plus y square. If xy is not equal to 0, then it is 0. If xy is equal to 0, 0. Show that fxy and fyx both exist in the neighborhood of 0, 0. That is, both exist. fxy 0, 0 and fyx 0, 0 both exist and are equal at 0, 0, but both are discontinuous at 0, 0. Now we have to find first fxy and fyx at 0, 0. So fx, the function is this. So we can find the fx by using u by v rule. So this is u by v rule, and the derivative with respect to x means y is constant. So the derivative of v, derivative of u, x square, y square, the derivative x square is y square is constant, and derivative of x square is 2x, right? 2x y square. Here is 2x y square. This is fy. I think this is fy. Fx. This is fx. So write 2x y square. Correction is here. And then u, derivative of v, derivative of this is what? X square, derivative is 2x, y square, derivative is 0, divided by x square. So we have this answer. Then fxy. Fxy means what? the derivative of this fx with respect to y. Again u by v rule, we have this. Okay, and fxy is this, and then fyx is also same because function is symmetric. And now what do I have to show? The example is what? Show that fxy and fyx exist in neighborhood of 0 0 and are equal at 0 0. Okay, so these fxy and fyx both are exist. Up to this, what we have, that fxy and fyx both are exist, but both are discontinuous at 0 0. Now we have to show these fxy and fyx are discontinuous at 0 0, not continuous at 0 0. But before that, we will find first fxy 0 0 and fyx 0 0. Okay, fxy 0 0. So again, fxy 0 0 is what? Limit k tends to 0, fx 0 k minus fx 0 0 divided by, again by using the same definition, substitute a and b as 0, a and b as 0, and find all these values, fx 0 k, fx 0 0, fy h 0, fy. So number, let it be 1 and 2. Then fxy, fx 0 k, fx 0 k is a find, it is fx 0 k, fxy 0 0. So by using this, we can substitute as this is fx, fxy. Substitute x as 0, x as 0, y as k in this. We can write directly or by using definition. Find all these values by using definition, and then we have both the value fxy 0 0 and fy 0 0 are 0. So find all the values of this quantity by using this procedure. By this procedure, find all the values by using fx 0 0, fx 0 k, then fx 0 0. Write definitions and find all the values and substitute. We get both the answers are 0. So both the answers are 0. Yeah, this is find. This is obtained from this data. This is wrong. This is wrong. Don't use this method. Use the fx 0 k. Find fx 0 k, fx 0 0, fy 0 0, fy 0 0, fy h 0, like this by using the definitions. This is the procedure. This is the procedure. Okay, so use this procedure, and then we see that fx 0 0, fxy 0 0, and fy 0 0 both are 0, and therefore these two are same. Here, what is the problem? Show that this fxy 0 0 and fy 0 0 both are same, but both are discontinuous, means fxy and fyx. This is fxy. Now we have to show this function is not continuous at 0 0. That is, show that the limit along different path is different, or find path such that the limit depend on path. So take y is equal to mx as path, and then limit xy tends to. So when fxy is the theorem that fxy is continuous at 0 0 if the limit of fxy as xy tends to 0 0 exists and is equal to fxy 0 0. Okay, so find a limit of fxy xy as xy tends to 0 0. So limit along path y is equal to mx, that is fxy x mx, and fxy is this, fxy is this. So substitute y as mx. So what we have? We have 8. Here is the calculation, that is substitute y as mx. What we have? We have 8x cube m cube x cube divided by x square m square x square bracket cube, and then take x. This is x raised to 6. We have the numerator is x raised to 6 divided by denominator. Take x square as common, so it's bracket cube, means we have x raised to 6 in bracket 1 plus m square bracket cube, and then x raised to 6 get cancelled. Write that step, and then we have 8m cube divided by 1 plus m square bracket cube, which depends on m, and therefore limit along different path is different, and therefore fxy xy as xy tends to 0 does not exist. The limit this does not exist. Limit of fxy does not exist, and therefore fxy is discontinuous or not continuous at 0 0. Then the next topic is level curve. We will see in the next lecture. The next topic, level curve.